Today we're going to be working on problem 5. So this is the information that's given to us in the problem, and we are trying to find the velocity, the drag on the blimp, and the power of our blimp. Starting off, we're trying to find our velocity of our water. So we have our Reynolds number of our model and our Reynolds number of our blimp, which we're going to equate. And we've already established the ratio of our actual blimp to our model blimp to be 13/1. So equating our Reynolds number, we know it's the velocity times the length over the kinematic viscosity. Solving for, or setting the equation equal to the velocity of the model, we can plug in our numbers that we have from our given information and find the velocity of our model to be 5.2 meters per second. Moving on to part B, I'm trying to find the drag force of our blimp, which we know the equation 1/2 times our drag coefficient times rho times our velocity times our velocity squared times our length squared, which we can equate to our drag coefficient as shown. We are going to assume in this problem that our drag coefficient is constant for our model and for our actual blimp. So we know that CD equals CD of our model equals the CD of our actual blimp. So we can set these two equal to each other and set the equation equal to the drag on our blimp. And plugging in the numbers that we have, we find that the drag is 607.8 kilonewtons. Moving on to part C, we're trying to find the power of our blimp, which we know to be the force times the velocity. We have both of those numbers, so we just go ahead and plug them in, and we get 4,070 watts. And that's how we do problem 5 today.